So, today we will be seeing about this chapter 14. Chapter 14 of 8th standard, the title is Chemical Effects of Electric Current. So, there is a car image. Why this image is there? What is the relationship between the car and current? It is not an electric car also. It's a old model car. So, why it is there? We will see. Okay. So, this chapter composed of like 11 pages are there. Like 2 to 3 activities are also there, which we will discuss in detail. So let's start what is that? Chapter 14, chemical effects of electric current. So that means current is there, and because of this current you are experiencing some kind of chemical effects. Effects in the sense you can tell some reactions are taking place, right? So first we will introduce what is current. You all see everywhere there this light is there, some current is coming, so because of that this light is getting blue. So you can feel like, let's start with a tube light, classical tube light. So you have one filament. They are connected in a circuit. Everywhere you need what is called a closed circuit. Like your train will go and track, right? So here also something is going. It could be a ion, or most of the case it is electron. Okay, electrons are going in a circuit. We need some source for electron. So it could be either a cell, battery, or directly from your power grid, which is coming there through multiple, like you have transformers that will control the voltage, then you are coming there. So some distribution center is taking care of that one. So some power source you need. I can just term it power source. So power source is coming, and you have wire. Wire is made up of metal. So you know metals are ductile. Okay, that means you can make it into some kind of wire. So here I am bringing it for your easy understanding. We know metals, they are all one, it is ductile, with which you can make wire. Second, they are all good conductors of electricity. That means it can allow the electron to flow through it. That means current is flowing through it. So you try to make a wire out of it. Then you have some kind of filament. Okay. So that means what is happening here? You are flowing some current. Because of that current, you release some ions and electrons. So that means some electrons is coming out because this is a filament. That means some kind of short tip you can imagine. So you are giving energy which is equal and more, so that you are kicking out an electron out of that metal surface. So because of this high energy, you are releasing the electron. So this is plus and minus. Basically, we will not go in deep like why, how, what is going on there. So at this level, we will try to introduce it. So some ions are coming in this space filled with some inert gas. So you have some inert gas. If you have some oxygen or any other air, that will, what I say, you have a tube, you have some balls, like you can assume air to be made of different molecules like oxygen, carbon dioxide, so on. Different balls are there. You are releasing some kind of ions also. So that will get impacted by these balls. So it will get interacted, and sometimes it will be absorbed also. So to avoid that, we use some kind of inert gas like neon lights are there. So neon lights, something like that. And you have some kind of coating, phosphor coating, where if the electron falls, then because of this one, you get, there will be a chemical change which will release the light. Basically, it will shine. So that is how the tube light works. So basically, you have a current, it is flowing through a wire, and it is releasing something, and you are seeing something. So you are getting the light. Now, first question is, current is flowing in this wire, right? So what is happening here? Am I seeing light here? No. Inside the tube light, because of this gas and coating, I am seeing something. So now we are extending this to the concept of chemical effect. If current generally flows in a wire, can you see some effect? Or do you need something else to see the chemical effect? Okay. We are starting here. So we will be discussing like some materials allow the current to pass through, some doesn't allow, you know. If you have a wood or rubber chapel, you can just walk because it is kind of a insulator which will not allow current to pass through. Okay, they are all poor conductors. They are made up of materials that will not allow the electron to freely pass through them. Okay, but something allows electrons to pass through. They are good conductors of electricity. You can name most of the metals, they are good conductors. Then what about non-metal? My classical example is like you have a circuit. Sometimes there is a discontinuity. You can just take the pencil, sharp two ends, and connect it. You can see the circuit gets completed. You are introducing a pencil which has a graphite hook. There is graphite hook. So that means it is a carbon. So carbon in graphene form, pencil hook, it can conduct because carbon is a non-metal. So there are some kind of exceptional case also. Non-metals also can sometimes behave as very good conductor. Like metal, you can tell silver is the good conductor, copper, so on. So we are making wires out of copper for electricity transmission. Some are like poor conductor. They will not allow materials to pass through. Like as I told you, have rubber, plastic, wood. They don't allow current to pass through. If you make a wire out of rubber, you will be losing energy only because rubber will not allow the current to pass through. Your TV will not start basically. Now coming to liquid. All these metals, whatever I am talking about, metals and non-metals, they are in solid form and you have a wire. So what happens when current pass through the liquid? Now only the game starts. Okay, you have a water. You assume there is a water. Okay, you dip the. Sometimes you can see right. There will be in news like sometimes there is a heavy rainfall, something like that. Your street is over flooded, and sometimes if there is a loose contact of the circuit, the transformer or some wire is there. What will happen? The government officials will tell don't go in that way because the water becomes conductive. It forms a circuit, closed circuit. And if you walk inside that, basically the water gets in contact with you, you are in contact. So you are also becomes a part of a circuit. So what happens? So current is flowing freely through you. Okay. So it will result in some kind of what happens? Basically, you will suffer. So idea is like what happens we will see. Because now current is entering into liquid, not solid. Now you are going from a wire to what happens? A wire gets dipped into some kind of liquid solution. Okay. So what happens? Whether current stops there, whether it will say I can flow through the wire only. Now you are introducing into a liquid. I cannot go there. What happens there? We will see there. So to flow, what I am telling still now is the term conductor. Something should conduct. If you have something like ions or any other material, ions in the sense I am telling about some kind of you have some metal ions, you have this. These are also same metal ions only, but I am trying to introduce into different form like acid, base. Some ions are there which try to regulate. They are more close to this pH of the solution, which brings into the concept of you have a acid or you have a base. So instead of water, you are having some acid base. That means you have either excess of H plus in water or excess of OH minus ions in water. So now the solution is not neutral. It is having excess of some kind of ion, certain ion, H plus in acid or OH minus in base. Okay, so you have now ions. So what happens? Ions are there. Ions means now it becomes conductor. So the term, the liquids that conduct electricity, they can conduct. They are all basically having some kind of ions. Ions could be either acid, base, or salt. Basically metal ions. Because if you have a salt, like say magnesium chloride, MgCl2, it will release magnesium ion, Mg2 plus, which is a metal ion, and chloride minus, 2 chloride minus ion, which is also a metal ion. So you have this salt. Salt can also break up. Basically, you are doing what is called ionization. Okay, something is neutral, it is becoming ion. So it is having some kind of charge. Either you can have excess of electron or you can have deficient of electron. Then also you become ion. Okay. So ionization creates ions. You can have two ions. One is positive ion, one is negative ion. I am introducing the terminology here. Positive ion is called cation. Negative ion is called anion. Okay. Now we are going now here. Now we are here. So we know if solution has some kind of ion. Ion could be H plus means acid, OH minus means base. You have some other metal ion like salt. So this makes this liquid to be able to conduct the current through it. You have sulfuric acid, hydrochloric acid, everything can conduct. Why? Because you have H plus. And you have vinegar, acetic acid, lemon as citric acid. Vinegar, lemon conduct electricity. They are also acid. Okay, why there are two lines there? One sulfuric acid, hydrochloric acid, they are coming in one line. Vinegar, acetic acid, citric acid coming in second line. Why? They are also acid, right? Here also you can see acid is there. Acid is there. Why? So there comes the concept. You can have two acid. One is strong acid. Second is weak acid. Okay, that means your acid sometime has a tendency to it should release these H plus ions, right? If it has more tendency, like it can release it very freely, then it is a very strong acid. Say for example, if you have HCl acid, it becomes H plus Cl minus rapidly. And if you have acetic acid like CH3COOH, it is very difficult. It is not that fast. It will form COO minus and H plus. It will also form, but it is a weak acid. So that is why you can remember like HCl, hydrochloric acid, concentrated sulfuric acid, H2SO4. Okay. They release that H plus ion instantly, like faster, then compared to some other acids. Okay, which makes them strong acids. That means they can have ions instantly and they can conduct more compared to weak acid. Same goes for base also. Okay, let me go up and write it here itself. Here, base. Base terms, you have excess of OH minus. Here also you have strong base and you have some weak base. Okay, strong base means it can form OH minus instantly. Like say you have sodium hydroxide, potassium hydroxide. They are all strong base. Okay, now they will dissociate rapidly, and you have different hydroxides also, but they are not that much important or relevant here. Okay, so I'm giving the examples here. So here sodium hydroxide and potassium hydroxide. Okay, they are the bases relevant for this chapter. Okay, they are strong base. So they will release what ions? OH minus ions. And coming to salt. Salt, you can imagine you have sodium chloride. It will also release ions. Okay, so some important difference in the conduction of electricity by solids and liquids. Okay, now we are coming to this point. So I told right, you have a circuit, battery you are connecting it, the tube light is connected to the battery by a wire. You are not seeing light or anything in that wire. You are seeing it only in the tube light. Why? Is current not flowing in the wire? But we know current is flowing through the wire. Reaction is not happening. So there comes this answer. In solids, current is carried by electrons. But in liquids, current is carried by ions. Either it could be positively charged ions or negatively charged ions. Okay, there is one important difference. In solids, these are called charge carriers. Okay, that is the terminology. What is the carrier here? In solids, you have electron. In liquid, you have ions. I will refer positive ion and negative ion like this way, in this way. So sometimes here the classical example has been given. Copper sulfate solution is there. So you have copper sulfate similar to H2SO4. Okay, you have Cu2 plus SO4 2 minus. If it is together, then two positive charge is neutralized by two negative charge, or else you will form this 2 plus two positive charges and two negative charges are being contributed by this copper sulfate salt. This is a salt. Okay. Now, the second important point. I told you, right, current is flowing through the wire, but there is no chemical reaction. Okay, that is why. Just what you can see, sometimes you have physical reaction. Okay, have you seen you have a bucket and you keep a heater rod? Current is flowing. Current is flowing through the solid only. Still now, this heater is also a solid. What happens? Heating happens. No chemical reaction, just a physical reaction. Current, it is converting from electric energy to heat energy. Heat energy. Just there is a conversion of energy from one energy to other energy, but there is no chemical energy. Electric energy is not converting to chemical energy, but to a physical energy, heat energy. Okay, but when it passes through a liquid, a chemical reaction takes place. So this is what I was telling. Like when current is flowing through a copper wire, you cannot see anything. But same thing, I have a bucket of water. I put the wire into it directly. Okay, it is connected to supply. So current is flowing. Now this water is in a circuit. Okay, water has, what is there in water? You have HOH. So you are giving some energy. What happens to the energy? Energy will reach the water. Agree, right? You are giving a water energy from this battery. Energy is flowing through the wire. Where it reaches ultimately into this water. So energy will flow into the water. Correct. So now what is happening? Water is taking excess of energy. So energy is there. Okay. Here I told you current energy is getting converted to heat energy. Right? There is a transformation of energy. Here also you are supplying energy to water, liquid. What will happen? I have drawn here, right, some kind of bond. This is bond which is holding H and OH together. If I give energy, it will try to break all these bonds. So you are left with two elements, hydrogen, oxygen. Hydrogen is a gas, oxygen is a gas. So hydrogen comes out, oxygen comes out. Basically, what you are doing, I told you, right? If you are giving some kind of energy to a liquid, okay, conductors are ions. Second thing, you are giving some energy. So energy is utilized to break a bond. Then what happens? It will ionize. Sorry. It will ionize. So basically you will get H plus ions, O minus ions, which are kind of unstable. They will combine to form H2O2. These are all gaseous elements. Okay. So two atoms of same type are combining. There is no kind of mixture or something. It is a homogeneous. H plus will combine H2. O minus combine O2. So they are combining. So to form this gaseous element. So you get hydrogen and oxygen gas. Okay. So here you are doing some kind of chemical reaction. You are breaking this bond. Okay. Now the energy is utilized to do some chemical reaction. What is that reaction? H2O, you are giving some energy and you are making it into H2 plus O2 gas. Okay, so there are two oxygen. So I should put two oxygen. So there are four hydrogen, two hydrogens. It's a balanced reaction, right? So I can write it in form of a chemical reaction. So this is what I was telling. When current passes through a liquid, a chemical change occurs. Okay, in copper wire you cannot see, but when the same thing passes through a water, you can see a chemical reaction. Water is getting decomposed into hydrogen and oxygen gases. This is what. You have two bonds, you are giving energy, so energy is utilized to break the bond. You have a stick, you hold it by two hands and you break it. So you are giving some kind of energy, you are spending some energy, muscular energy, work to break that stick. Okay, basically that is a physical change. You are saying there is a breaking, but here that energy, current energy is being utilized to break that bond. That's a chemical change. Okay, so now we have slowly introduced one chemical change here, right? Water, if I dip some wire carrying current, you are experiencing some chemical change and you are releasing hydrogen and oxygen. Okay, in liquids, you are seeing some kind of chemical change that you should be clear till now. Now, this is what the chemical changes, whatever is happening, right? One of the example I gave you. When conducting liquids come in contact with current. These are called the chemical effects of electric current. Okay, so one example I have given. So that means this chapter will be giving you some more examples in this way. Like what happens if I put a current wire into something? What kind of reaction we will see? And is there any use to read that one? So we will see. Okay, so there are some new terms are coming up. Electrolyte, electrodes, anode, cathode. Oh my god. So first we will start with what is an electrolyte. Okay. Sometimes whenever you have fever or some diarrhea, what you can see, you are losing your water. Most of the time you will lose your water. That time doctor will prescribe you some kind of electrolyte solution, say ORS. Basically a salt solution. You take the powder, mix it in water and drink it. Okay. So you are basically that time you are losing whatever electrolytes you have in your body, ions. It is going away. You drink it so that you are trying to maintain it. So that means basically you are losing some ions in your body and you are trying to give that ion. So that solution gets balanced. So that solution containing ion is called electrolyte. The clear definition is any liquid that can conduct electricity. Basically, the liquid contains ions. Okay, then it can conduct electricity. It is termed as the electrolyte. Okay, it has some kind of material, substances that can form ions. Salt will be there. Say copper sulfate solution. Copper sulfate is a salt. You know, right? Now, the copper sulfate, if you put it in water, you have copper sulfate in water. First the equation what we show. Then, if you put like then it can dissociate freely. Salt, right? It will dissolve and dissociate. It will form copper ions and it will form sulfate ions. So now you have ions in the copper sulfate solution. Then it can conduct. Then it makes copper sulfate solution an electrolyte. So a conducting liquid contains ions, both positive and negatively charged ions. Okay. So in this case, copper sulfate, I will write copper sulfate. You have powder. You dissolve it in water. So you form copper sulfate in liquid. Basically, it will dissociate to form copper ions and sulfate ions. So you have two ions. So this solution is the electrolyte. This is salt. Okay. Now, as I told, right, acid, if it releases H plus more faster, it is a strong acid. Similarly, electrolyte also, you have the definitions. If it is a strong electrolyte or is it a weak electrolyte? Okay, strong electrolyte is something which conducts current very well. Okay, if something can conduct current very well, then it is a strong electrolyte. Okay, that means it has lot of ions in it. If I take a solution and I put more of ions, then there are lots of ions to conduct the current. Then current will move faster. That means it is conducting current well. Then that solution is a strong electrolyte. Okay. If on the other hand, if I have very less amount of ions in a solution, basically I take a water, pure water, no salt at all. Okay, there is a term. Salt water is a good conductor of electricity. Okay, I'm introducing salt water. That means water containing salt. That means ions are there. then it can conduct. Then it is a good conductor. Then it is a strong electrolyte. Then what happens to just water? Water doesn't have salt. That means it doesn't have that much ions compared to salt water. That means it cannot conduct electricity that much compared to salt water. So it is not a good electrolyte. It becomes weak electrolyte. Okay. So a weak electrolyte, it conducts to a less extent. Say all these acids, HCl, nitric acid solution, HNO3, NaOH, KOH, NaCl, CuSO4, AgNO3, everything has ions, more ions are there. So it can conduct current very well. So they are strong electrolytes. Now coming to weak electrolytes. So weak electrolytes are, this is a weak acid, I told you right, vinegar, lemon juice, everything. They are not able to dissociate that much faster compared to a strong acid. So it is not releasing H plus that faster. That means H plus is not coming. That means the number of ions in the solution is less. That means conductivity is going down. So it is a weak electrolyte. Examples are vinegar, lemon juice, citric acid, carbonic acid, even soda, and ammonium chloride, salt. NH4OH is a weak salt, weak base, not that strong as sodium hydroxide. And ordinary water. See, this is the term ordinary water. Salt water goes into strong electrolyte condition. If you have ordinary water, it is a weak electrolyte. Okay, now there is a terminology. Electrode, a solid electric conductor through which the current passes. Like you have a battery. Battery is giving the current. You connect a wire through it and you put the wire ends into a solid material. That material is called an electrode. Basically, it's a rod. You have a rod and you connect this to a cell. These two rods are electrodes. Okay, now I am going forward and I am introducing this concept. You have plus charge and minus charge, right? Plus charge is connected to this rod. So this rod will have plus charge. This rod is minus charge. So this rod will have minus charge. Okay. Then what attracts plus charge? Basically minus will come close to plus charge, right? And plus will go close to minus charge, right? But previously I have described you. Okay, here I am introducing. Plus is cation. And what is anion? Red color. Minus is anion. Okay, but we have introduced the term here. Cation is plus, anion is minus. So, which is going where? So, anions are going to plus electrode. That means it is called anode. Cations are going into minus electrode. Then it is called cathode. Very simple. Okay, very simple. So, positive terminal is connected to one rod. So, that rod will be positively charged. Negative terminal is connected to one rod. What is that rod? Here you have the definition. A solid electric conductor through which the current enters or leaves, like a dry cell or an electrolytic cell, is called an electrode. So this rod comes in contact with the electrolytic cell, which we will introduce. Okay, so these rods are called electrodes. This is a wire. Okay, just wire. Okay, electrodes. So positive charge, this rod electrode will be positively charged. So negative ion will come to positive because positive negative attracts. So negative ion is called anion. Therefore, since anions are coming to this rod, then this is called anode. Then similarly, negative charge is going to this rod, this electrode. Then what will attract the negative charge? Positive ions. So cations are going to this negatively charged electrode. Therefore, it is called cathode. So you have different metal rods. It could be metal or non-metal. Non-metal could be carbon. The names are anode and cathode. So this is what electrode connected to the positive terminal becomes positively charged. Then negative ions come there. Negative ions are anions. So that is why it is called a anode. An electrode which is connected to the negative terminal, it becomes negatively charged. What ions come there? Cations will come there. Therefore, it is cathode. Okay. Here you saw like there is a term electrolytic cell which I didn't talk. So you should have a tub-like structure. There will be a tub. You can consider a tub. Okay. You fill some solution. What is that solution? Solution contains some ions. That is called electrolyte. And you dip these electrodes to it. So you have positive, negative. Positive comes here, negative ion attracts. So this is anode, and this is cathode. The ions are coming from this electrolyte. Electrolyte has both positive and negative. So this negative will be more here, and positive will be more here. This tub is called the electrolytic cell. It is basically an arrangement to keep the two electrodes in a conducting liquid. So this container is called the electrolytic cell. Okay, it could be a tub or a beaker or any other vessel. Basically a vessel. Okay, then the chemical reactions will be carried out. Okay, so the current is passing through these electrodes into this electrolyte. Then the chemical reaction is taking place because as I told, if the current is flowing into some solid, there is no chemical reaction. That is the first point. When it comes into liquid, chemical reaction takes place. Okay, now chemical reaction happens in this electrolytic cell. So now come to the next concept. The conducting liquids are not as good conductors of electricity as metals are. What is this? I told you right. One of the example which we are discussing till now for the electrolyte or the conducting liquid is the copper sulfate in water. Copper sulfate in water. But here they are telling that electrolyte is not the conductor. There is also copper sulfate. Copper rod is electrode. And copper sulfate is electrolyte. Why? We will see. So now what is there here? So this is a conducting liquid, electrolyte. Okay. What happens is in solid copper, something will happen, that reactions we will see. And in liquid, as I told, right, plus and minus, will these ions stay infinitely? If you don't disturb or don't do anything, it will be there. If you add 1 gram of copper sulfate in water, you will get some amount of ions, say 100 ions of copper, 100 ions of sulfate. It will be there in water. Okay. And if in some case, I'm telling that constantly there is some kind of chemical reaction, something is happening. If because of that, if there is a decrease in the ions, then the ion number is going down. Then ions are giving that conductivity property, and the conductivity property is going down. Okay. Then the conductivity property of this electrolyte is going down compared to a solid material where nothing is happening. Okay. A solid wire, there is no chemical change. So nothing will happen. Whatever ions are there, it will be there. Okay. Basically, whatever electrons flow, it will be there. Nothing will happen. So that is the answer. Okay. So there is some change in this ionic concentration. Ions will what might get consumed during chemical reaction. So ions are getting consumed. Then ions number going down. Then conductivity going down. So electrolyte conductivity is kind of less than a metal conductivity, because here there is no reaction or action. Here there is some chemical reaction short form. Okay. Now we will find whether a liquid conducts electricity or not. Simple, right? I told you how to find metal and non-metal. Something like that. This is one activity. So we need to have a circuit. Then only we can do this experiment. So basically you have this here. Now I can demonstrate easily. This is a battery. So it is a source. Okay. So it is flowing through these wires. There are two strong dark things. So these are the electrodes, solid material. And this is a liquid. So this is an electrolyte. And this is there in a tub. This tub is the electrolytic cell, and there is a bulb just to detect. So we want to see whether that is uh, electrolyte or not. That means it is a yes or no. You should have something to detect and tell, hey, it is yes or it is no. So if bulb glows, then it is conducting. That means it is an electrolyte. If the bulb doesn't glow, that means the current is not reaching here. That means it is not conducting. Then it is not an electrolyte. So that is the example that we will discuss. So here the example is one side you have the hydrochloric acid solution. Second side you have the sugar solution. Okay, basically in sugar is also like you can assume C12H22O11, that is sucrose, sugar. You can tell easily, hey, here HCl, it can form H plus ion and Cl minus ion, right? Which are ions, right? HCl will form the ions. So ions are there, so it can conduct. Becomes a conducting liquid. So electrolyte can conduct. So this will allow the electrons to flow, and here ions will flow. These ions will flow. Then current is moving from here to here. Then again it will go back. So bulb will glow. Yes. So HCl is a conductor. Yes, double tick. Sucrose is having H, right? Here also you told H plus is there. Here also H is there. It can also conduct, right? But this cannot dissociate and release the H. H is not free. Okay, H is not free. There is a concept hydrogen bonding, and it is very strong. It is strongly bonded. It is not releasing this H plus very freely. Okay, there are no ions. So electron will start here. It is flowing. Electron is coming here. It is coming till here, and it is seeing is there any ions to transfer. But there is no ions. Then it cannot go. It is stopping here. Then you cannot finish this one. Then there is no one to go to the bulb. Then the bulb doesn't go blue. You cannot see a light. That makes sucrose a weak. It is not an electrolyte. Understand, right? So you want to see current is flowing or not. If current is flowing or not, to detect it, you need a bulb. Okay. Then you have this setup. This setup is called the electrolytic cell. You need an electrolyte. Here we are testing two solutions, whether it is an electrolyte or not. One side we have this HCl. Second side you have this sugar solution. Then you make a circuit by connecting battery to some electrodes. Till here electron will flow because it is a solid. And in liquid, ions will flow. If your electrolyte has ions, then the current will flow. Here in HCl you have ions. Then the current will flow through the liquid. Then it can go to the bulb. Bulb will glow. It's an electrolyte. In sugar solution you don't have any ions. Therefore current will stay till the electrodes itself. There is no ions in the solution. So current will not flow through the liquid. So the bulb will not glow because there is no circuit completion. So now coming to weak conductors of electricity. I told you sugar, there is no ions at all. That means it cannot conduct. Okay. So it is not an electrolyte at all. Now what happens if there is very less amount of ions? Ions are there, but it is very less. That also we can test. We told right, you have acids, you have something strong acid, and you have something weak acid. Strong acid has more H plus, weak acid has less H plus. It is less H plus, not no H plus. It is there. Something is there, but in very small amount, less. So it can conduct that we will see here. That is the example. So that means this is a cell. You can see this is a very beautiful compact electrolytic cell. So you have a source, current is coming here and it is reaching the electrolyte. Here in this case it is HCl. So HCl has ions. So it will conduct it. Again it will reach here and will release the electron. So electron will go to the bulb. Bulb will glow. Super. If I have here vinegar, basically acetic acid, which will release ions CH3, COO minus. This is anion and H plus is cation. Ions are there, but it is not that much getting dissociated and releasing these ions. Some population will be staying as this form also. This is neutral form. It cannot conduct. So there are few ions are there. So that means when current goes to this RAD, electron is flowing. Then again it is reaching here. So it can see some ions. So the ions will move. Therefore, the bulb is glowing not that much, dim. It is dim, very dim. It is there. So that means your vinegar is also an electrolyte. Now, okay. Now, in case you have ordinary water will have some ions, some ions. Salt water has more ions, so it is a strong electrolyte. Ordinary water has some ions. Then the bulb, if it has some ions, then the bulb will glow dim. If it is a very pure water like aurum membrane or something, you filtered and removed all the ions, reverse osmosis membrane, then water doesn't have any ion, then the bulb will not glow. It depends how much ions is there. So the bulb may or may not glow. Now, as I told right, we need some detector. Basically, detector in that case we use the electric bulb. Sometimes whatever current is going is very small. It's a weak current, very too weak current. Then that cannot turn on a very big bulb. You should have a very small bulb. Okay, because the big bulb it will not get heated up, it will not release that electrons, it will not so the electrons will not flow on the chemical coating and it will not release that light. The bulb doesn't glow at all. But something is flowing. So you should have something small. A big bulb cannot detect a weak electric current. Weak electric current. So to detect weak electric current, you need something small. One could be either LED, second could be some kind of compass. Okay, here you are doing directly same electric current to light. This is light direction. In compass, you use some current is converting to magnetic field, which will move the compass. That also you can do. Same. Here you have the compass. Okay, the current is there. Now the current is flowing through this wire. Okay, it will go here. It will go here, 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 here. then it is producing a magnetic field. B is the magnetic field. So magnetic field is there. Therefore, you can detect it. North to south, this compass will show. So there will be some kind of deflection in the needle. Okay. So the current, it is a weak current that is flowing, very small amount of current. But since current is flowing through that wire, it will generate what is called magnetic field. So that magnetic field will deflect that needle. Okay. So that is also a way. So if there is a deflection, that means magnetic field is there. That means some current is coming. That also you can use as a detector for detecting weak current. So we told right, this vinegar, lemon juice, tap water, rainwater, seawater, distilled water, they have very much, very, what I say, less amount of ions, very less ions. Number of ions is very less. It is not like no ions, it is less ions. That means very less weak current you can see. So you can use a compass, that is where you can see a deflection in the magnetic needle, or you can use a LED. So here distilled water doesn't conduct electricity because you have this water. What is distillation that I will introduce here? Okay, you have this water. Water is having ions. All ions are there. Then you boil this water. Then it will become steam, right? Then you collect that steam. Okay, you are collecting that steam and you condense it. So you have a condenser. Okay, you supply cooling water. So this cooling water will take up all the heat. Steam is very hot, right? This is hot. And you use cooling water. This is called a condenser. We will not discuss in detail about this principle. So we are trying to condense this steam into water. Okay. What is evaporating here? Water is evaporating or ions? Only water, right? So ions will be left here. So now whatever water you got, this is called the distilled water. So only water boils, not the ions. So you are collecting the water vapor, not the ion vapor or something. Water vapor is coming and you are condensing that water vapor and you are getting pure water, which is free of ions. So it has no ions. So that means it cannot conduct electricity. If you add a pinch of salt to it, that means you are introducing ions. So if you add NaCl, now ions are there. You have lot of ions because NaCl is contributing to this one. Then it becomes a conductor or electrolyte. Okay, that means you can convert something a non-electrolyte to an electrolyte by external addition of a material which can release the ions, create the ions. So this is the take-home message here. So we can make distilled water to conduct electricity by adding salt. You can add salt, or you can add acid, you can add base, because salt will release some ions, right? Na plus Cl minus. Acid can also release some ions, like say H plus Cl minus or HCl. Base can also release ions, Na plus OH minus. So it is a conductor. So now most of the time water that we get from our sources like taps and pump well ponds, they are not pure. So they will have some kind of salt in it, like say beach water. Beach water has a lot of salt. Okay, that makes it a good conductor of electricity. Okay, wow. So tap water is also example. So that is why you should never operate an electric switch or something with wet hand. So it is dangerous because now the wet hand contain ions, right? So you are a part of a circuit now. Basically, while firefighting, they always cut off, they will switch off all the currents in that area. Then they will use water. Okay. Or else, whatever current is there in that building which caught fire, it will come into that water because water is a conductor. Because they are taking water from somewhere, either from the building, tap water, beach water, or something. So, tap water is drinking water. Drinking water contains small amount of salt. But seawater contains lot of salt. That is why seawater is a better conductor of electricity than drinking water. Rainwater is a pure water, but when it comes in contact, because right now we have introduced a lot of carbon dioxide in our atmosphere, that will react with this water, rainwater, and it will release some amount of carbonic acid. Okay, so this acid it can dissociate into H plus and carbonic H2CO3, HCO3 minus. Okay, some carbonate ions will be there. So that carbonic acid, it is also a conductor. So that makes rainwater a good conductor of electricity. So when rainwater is highly pure, that time it is not a conductor. But when it comes in contact with our atmosphere, there is some reaction. Carbonic acid or sulfonic acid, sulfuric acid, nitric acid will form. Then it becomes a conductor. That is why when rain is there, whenever there is a rain, that time you should not do any kind of electric repair because whatever water that is coming, it has entered our atmosphere. Now it has trace amounts of carbonic acid, sulfuric acid, nitric acid. Basically, it is a mild acid rain. You can write down mild, very mild acid rain. Okay, so that is a conductor. Now, whatever you are repairing, that can become a conductor. It will react with that water. So current will flow from that equipment into water, and you are also there. You will be a part of the circuit. Okay, so here is a problem. So you have a circuit, and you have a source, and you have a bulb. Bulb is not glowing, and you have a conductor. What all reasons could be there? You can switch it this off. This could be switched off. There is no current, or this bulb is gone, means fused out, or this is not a conductor, not a not an electrolyte, or this is a weak electrolyte, but this is a big bulb. Okay, for weak electrolyte, you need either LED or a compass to detect if everything is working fine. Okay, these all could be the possible answers. Why? In case if you replace it with LED and it is a weak electrolyte, then it will glow. That could be one of the possible things. So I was talking like there is some kind of chemical change, chemical change. This we have discussed extensively. Like if you dip a current, that is a wire or electrode into water, there is a reaction which will produce hydrogen and oxygen. Both are gases. So this is called decomposition reaction. It will decompose, break down, chemical decomposition. So this is called chemical decomposition. Another term is called electrolysis. You lyse means break. You break with the help of current. So water, you are breaking it into hydrogen and oxygen. As I told, right, you are giving some energy, electric current, that is being used to break the bonds. Then you are releasing hydrogen and oxygen. So now we will demonstrate the chemical effect of electric current. Okay. So this is an effect. Now we are coming there. What is happening here? What is happening here? Now you can see there is a mention about these electrodes. So you have a circuit. Current is going through the wire to electrode. This is plus. So negative will come and attract here. So this is called an anode. So here negative charge is going there. So this rod is negatively charged. So positive ions will come and attract here. So this is called cathode. Okay. So this is an electrolyte, that is acidified water. You add that some water, sulfuric acid to it. So there are ions, plus and minus. So what is happening here is, so it is conducting, right? You immerse the rod, so current is flowing through the rod. Then wait for 5 to 10 minutes. Then you can see there is some kind of bubbling. Here the bubbles will form and some gas will release. Okay, so you can think, right? You have positive and negative. This is positive. This rod is full of positive. And you have negative. What is negative here? Sulfate. This is sulfuric acid. So you have positive H plus and negative sulfate. That means this sulfate negative is getting positive charge, right, from this battery. Then it can become neutral. Then it can form sulfate gas. Okay. Here you have this H plus. It is taking that negative charge here. Then it is becoming H, hydrogen, H2. So it will release that one. So you are trying to decompose this H2SO4 into H plus and SO4 minus. H plus will become a H2 gas. So that is how. In water, you can see here the take home message is positive ions will form one gas, negative ions will form other gas. Okay. In water, you have two ions. One is H plus, O minus. Which is positive ion. This one is positive ion. Okay. So this positive ion, where it is going, it will go to cathode. This will go to anode. Okay. Cathode has negative charge. Anode has positive charge. Then it will become H2, neutralize. Plus minus will be neutralized. Minus plus will be neutralized from O2. So that is why oxygen is formed at the positive electrode or the anode. Hydrogen gas, it is formed at the negative electrode or the cathode. Very simple. So I told you, right, when current is passing, it will break up the ions. That is called electrolysis. Okay, reintroduction. What happens is, you can see some of this. The bubbles will form. If it is a gas, bubbles will form because it is going from liquid hydrogen in liquid form to hydrogen in gas form. It will form bubbles, or else sometime it will get deposited on that electrode. You have an electrode, ions are coming, you have plus ion, plus ion, plus ion, and you have this negative charge of this one because this is a cathode. It is connected to negative terminal of the battery. Okay, so this will react and deposit here, neutral element. Because of this deposition, sometimes there could be change in color also. Solution color will also change. That we will see. One example might be there. So the whatever effect you want, it depends on what electrodes you are using also. Okay. So now we are seeing some example. We will see some example where mm, Okay, here the example is color change example. What will happen when current passes through a potato? So now we need to sacrifice one potato. Sacrifice one potato and put two nails. These are the electrodes. Connect it into some battery and you need a detector. So this is power source. You need a detector and you have these electrodes. This is negative. Positive ion will come. So this is cathode. This is positive. Negative ion will come. This is anode. And this is the potato, electrolyte. I can tell electrolytic cell because whatever is inside that potato which will conduct, because potato is made up of, it is organic matter. There will be water, ions, everything will be there, salt and minerals. So those are the electrolytes. Okay. Now current is getting passed and there is a deflection in the compass. That means current is passing through the potato. After half an hour, you can see greenish blue spot on the surface. Green color. What is happening there? That too around the positive electrode. Okay, and that too around the positive electrode. So that means green color. So there is some kind of deposition or something. You will see why. And this is iron nail. Okay, so you can straight away guess something is connected to iron. Why it is coming? Why to that positive electrode only? That we will discuss in detail now. Okay, I told you right. Greenish color is coming. Greenish blue color. That too around the positive terminal. Okay, why? Because you told that is a iron nail. So something, the green color has to do something with the iron deposit. Okay, but why it is happening? What is the principle behind that? We will see. So there are multiple applications by using this concept. What we learned, like when current passes through some kind of liquid, you dip some electrodes, you will see some kind of chemical effect. The chemical effect of color electric current can be used to electroplate metal, purify metal, production of certain metal, production of some chemical compound, and decompose it. Okay, some decomposition I am writing. You have sulfuric acid and you try to break it into H2 and sulfate ions. This will deposit. Or you can produce hydrogen gas from water. Sometimes you can do coating. Okay, so now comes to electroplating. Electro means you are using current to plate something. Do some coating using current. So the first application, that is number one, electroplating. So you can see this kind of shiny, very shiny, lustrous. So something has been deposited. Okay, that is chromium, Cr. Because this is a iron tap or copper tap. Gold tap is there, but you have chromium coating onto that one, which makes it shining. So how to deposit? So you can deposit a thin layer of your desired metal, here in this case chromium, onto any object, a old iron tap, by using current. That is called electroplating. So why we need to do it? So it will help prevent corrosion and for decorative purpose. You can see it is very shiny, decorative. Something is there. Basically, you can use like this one: chromium, silver metal, tin, shining metal, tin and nickel, silver and gold. That is called gold plating. Basically, you take silver particle and you coat a layer of gold. So then you plate the silver article. Basically, it is a fake gold. Gold plating looks like gold, cheaper gold. Like say you have a silver, a metal object is electroplated with silver, it is called silver plating. If you coat nickel, nickel plating. If you coat tin, tin plating. If you coat chromium, chromium plating. If you put gold, gold plating. So now the metal object on which the electroplating is done is made the negative electrode. Okay, that is very important point. And the metal whose layer is to be deposited is the positive electrode. So here in this case, tap, iron tap, it is the negative electrode and the chromium sheet will be the positive electrode. Okay, then you have an electrolyte. Okay, water soluble salt of the metal to be deposited. That means something to do with chromium, chromic oxide or something should be there. Then only the chromium will pass from this metal into this solution and into this tap. Okay, how it is happening we will see. Yes, so here you have one key. Okay, you have a volt key. Not a knife. Okay, key iron, and you want to coat copper onto this key. So now remember the points. Whatever object that you want to coat is the negative electrode. Okay, so this one is negative electrode, basically cathode. And whatever you want to coat, that is the anode. And the solution is more relevant to what you are coating. So that means the solution is close to copper. Means copper sulfate electrolyte. Okay, and that is the answer. In this way, you need to set up the experiment. So here, this is negative, right? So positive ion. So this is cathode. You put the iron key, and this is anode. You have a copper metal, copper plate. Okay, and this is the copper sulfate solution. So now, if you pass current, the copper from here will go into this solution, and from here it will get coated onto this iron. So now the iron key will be coated with copper. But you can just simply remember what you want to, what material you want to get coated. Like, for example, if you want to cover a tap or cover a key, you put it into, use that as a cathode. And if you want to do a gold plating, use gold as a anode. And you should use some gold solution as electrolyte. Okay. For chromium coating, you should use chromium as the anode and some chromium solution as electrolyte. Silver plating, silver should be anode, silver solution should be electrolyte. But what is happening there? Are you curious to know what is going there? Okay, so this is the process. Okay, as I told, here there will be some space. Okay, first we will see the cell. You have this positive, negative. Okay, one side is positive, second side is negative. Here in this case, cathode is right side, anode is left side. This is anode, this is cathode. Okay, this is the key, and this is the copper piece, and this is copper sulfate. Okay, now when you pass current, so as I told, first current will separate this copper sulfate into copper and sulfate ions. This is called electrolysis, chemical decomposition. So it will get separated. Now you have plus and you have minus copper and sulfate. So sulfate will go here, negative, 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 negative. Positive will go here, positive, 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 positive. So what is positive here? Copper, right? What is negative here? Sulfate. Understood? So copper is going here. Copper is, so copper is plus and it is facing that electrode which is having negative charge. So plus and minus will become 0. So now copper becomes a metal. It is not an ion anymore. Just the copper will get deposited here. Okay. So now whatever ions are there, it is getting deposited. So there will be depletion of ions in the solution. So what happens to this side? That is anode. So this is cathode, right? So in anode, you are getting some sulfate ions. And also in the solution, the positive ion level is going down because the positive ions are getting deposited onto this cathode. They are getting sticked and getting coated. So that means this will automatically dissolve and form ions. So here you have pure copper. This will become ionized, release two electrons. Okay, because two electrons have been neutralized. Basically, you have an ion that went into a negative terminal, cathode, which is having two electrons. So it is taking the two electrons and getting neutralized and getting deposited here. So you lost two electrons now. For maintaining a supply, you need the two electrons. So this copper again will dissolve and become ion. Now the levels of these ions in that solution, this is the tub in that solution will also rise, and you have the two electrons again, which will circulate through the circuit. Again, if it encounters one more copper ion here, it will get neutralized. Therefore, you have the copper coating. So it is some kind of issue. Mhm. So that is the concept here. So the concept is from solution, it is going to first we will see what is happening there. Cation is going to cathode, right? So the cathode is having negative charge and cations are coming there, coming and getting neutralized. So they are not ions anymore. So then that cations, neutralized cations, basically atoms, will get deposited. So the levels of cations will get decrease in the solution because it is getting neutralized. So to compensate, in anode, atoms will ionize and release electron and cations into solution. Okay, so basically you can think here that is called oxidation. You are losing electron. Electron is getting lost from the atom. Here, the ion is picking up the electron and getting reduced to atom. So basically, reduction is happening. Simple. So that is why wherever the ions will here see the atoms are it, cations are getting neutralized and forming atoms, which will be deposited. So whatever metal you want, whatever object you want to get coated, you should keep it in cathode. Then only the atoms will get deposit. Okay. So let me use the scroller to go down. Now this is the example, like you can use any material, put it in place of cathode, and you use some chromium as anode. Okay, and you use a chromium solution for electrolyte, then the chromium will go from the anode into the electrolytic solution, and from electrolytic solution and gets deposited onto the cathode. So in this way you can make these kind of cycle parts more shiny, chromium coated. So you can put silver also, silver and gold. You can take any silver or copper and put it in that cathode. This cathode. You can put any silver object. You can put some gold sheet into a gold solution. Then gold will go from here to here by process of oxidation. Then here to here it will get deposited. Gold will deposit. We use a gold color itself. So gold from here it will go into solution. Then it will get deposited onto this silver. What is happening here? It's a reduction to metal. So that is the most important problem. The conducting solutions, whatever we have set up one electrolytic experiment, electrolysis experiment, then we have coated one iron key with copper, then we coated some cycle parts with chromium, then we coated with some silver article object with gold. Then what happens to this solution? Generally, they are like doing some kind of nonsense way, some illegal disposal is going on. You should dispose it properly. Whatever things, whatever solution or any metal that has been generated by this electroplating process has to be disposed properly. It should not pollute. It should not pollute. You should follow the government rules. Sometimes you can use to extract a metal also. You have an impure metal. That means you have metal and some dust. Okay. So what you can do is you need pure metal. What we know, it will go from anode to cathode. That means you should put the impure metal. You are going from what you are going. Impure metal to pure metal. Impure metal to pure metal. Like you are coating pure metal. Okay. So you should have some pure metal as cathode. That is what the idea is. You should have a thin strip of pure metal as cathode. Then you should have whatever impure metal as anode. Then the metal will dissolve, that is oxidize from this anode and go into the same metal solution. Okay, but these are pure ions, pure metal ions. Then it will reduce at cathode and get deposited onto this pure metal. Then this pure metal will become more thicker and thicker, thicker and thicker. In this way, you are trying to purify the metal. So this is an example. You have impure zinc rod. So zinc, copper, copper plus dust you have. It is connected to positive charge. Negative ions will come. So this is anode, and this is cathode, where coating will happen. So you are going from impure to pure. So you should use some pure copper. So this is what they use. So impure metal is anode and pure metal is cathode. So copper will go into this copper sulfate. Okay, copper sulfate, and from here it will get deposited onto this copper. Now it will get shrink. It will get increased. And what happens to the dust? Dust will settle. Now you bought a pure metal. This is pure metal. You can take it out and use it. So in this way, metals can be purified. Sometimes when you take from the that is called ore, metals naturally occur at ore. So they will have some kind of sand, dirt, any other impurities will be there. So you can keep that as in that place of which one? Anode. You should place it in anode. And you use some pure metal as cathode and use an electrolyte solution. Then you can get the metal at the cathode, pure metal. So pure metal is produced at the cathode, negative charge. And all the waste will be settled down in the electrolytic solution. But for doing all these things, you need current. Okay. So if you have a salt solution, you can produce sodium metal from that one. Same for aluminum also. Now there are only two concepts of pending. One, how to produce metal that we have discussed here. First, we saw about what is electroplating. Then, can we extract metals? That also we can do. You can have an impure metal with the sand and dirt, impure, and you have some pure metal, pure. It will go into solution, then it will get deposited. Okay, and that is the idea behind idea. In this way, you can purify that metal. Then you can purify some compounds also, like sodium hydroxide. From sodium chloride, you can get sodium, something like that. So you can produce some compounds also by using this chemical effect of electric current. Or you can do the decomposition of some compounds also, which I told. You have HOH, water, you use some energy and break these bonds, then you release H2 and O2 from the respective electrodes because H plus will go to which electrode? Anode. H plus is cation, so it will go to cathode. O minus is anion, it will go to anode. Right? So anion, it will go into that electrode, that's anode. So you will get in anode O2 gas, in cathode you will get H2 gas. You can put two different tubes and try to separately collect hydrogen and oxygen. Okay, so while finishing, I will give the take home message to you. So, number one, we will start. Current goes through solid, no chemical reaction. Current goes through liquid, some chemical reaction. Second, what are the charge carriers? In solid and in liquid. In solid, electrons are charge carriers. In liquid, you have ions, plus and minus. Then you have the terminology. A conducting liquid is called the electrolyte. It could be strong or weak. If it is a strong, you can detect it using common bulb because it will produce, it has more conductance, more ions, more electric conductance, so the bulb will glow. Weak electrolyte has less ions, therefore less electric conductance, then therefore less electric current. So you should use some special like LED or a compass. Compass uses magnetic field, electric field to magnetic field conversion. Then you have these ions and electrodes. First, cation is positive charge ion, anion is negative charge ion. Okay, cation will goes to like say you have a battery, you have these rods. These rods are called the electrodes. Okay, then you put it into a tub. This is called the electrolytic cell. A tub is filled with some solution that is called the electrolyte, which will decompose into plus ion and minus ion upon passing current. So this is plus, so this is plus, this is minus, this is minus. Okay, current is flowing. So negative ion will come here. Negative ion is anion. Therefore, then this is called anode. Here, positive ions are coming there. Then it is called cathode. Very simple. Now fifth, we are doing electroplating now. Okay. So whatever object you want to coat, I am giving that tap with chromium. So you need to have a sheet of chromium one side, and you need to have the metal tap on the other side, and you put it into one solution of chromium solution. This chromium solution, and you connect the current, but which side to which side. So it should be negative, this should be positive. Then this is negative, that means this metal is negatively charged. Then what ions will come here? Positive ions. Then this is cathode. This is positively charged. What ions will come here? Negative charge ions. That means this is anode. So what happens here? What happens here? So the chromium will separate into chromium ion and electron. This is called oxidation. And now you are releasing two electrons and chromium ions into solution. And this one will slowly go and reach here, this tap. This is having excess of electron because this is negative, right? It means it is having electron. So what happens here? This chromium, whatever came, will react with the two electrons and will become chromium metal or neutral atom. Now it will get deposited. Now I use a different color. This is chromium. Now this chromium ion is going here in this solution. Then it will slowly get deposited onto this tap. In this way, you are using current to do the plating. This is called electroplating. So whatever, here the take home message is object to be coated. That should be cathode. And the metal that is coating metal should be anode. And the electrolyte is related to coating. So it should be same. Then only chromium will go into chromium solution. It should not be something iron or something. It should be same. If you have here the tap, here you have chromium, then also it should be some chromium solution. Okay. Now one more example I will write. Here you need to coat silver object with gold. You should use some gold solution. That is the take home message. Then 6 to 1. Can I purify metal? Yes, you can. Use a ore, that is pure metal plus impurity. Now we will purify copper purification. So this is copper ore. Okay, what I told, whatever should be coated. Basically, you have the same definition, cathode and anode. What I need to keep, the object where you want to apply that coating should be the cathode. Here I am going from impure to pure. Okay, I am taking some coating. This is the coating. From here I am taking pure. pure copper. I am taking from here and I am putting it there. So this is the paint. So I should take here, and this becomes the object. So this is the pure copper should be the cathode, and you should use some copper sulfate. So what happens here? From here, copper will get oxidized to copper and electron and go into solution, and it will reach here, which is negatively charged. These are negative, so this plus will go here. This copper will be here. Cu plus or Cu2 plus, depending on that one, it will get neutralized. It will reduce. It will form the atom. That is, it will deposit. Pure copper will get deposited slowly onto this again pure copper. Then the pure copper increases. Then there will be some kind of impurities. Then impurities will settle down. These are impurities. Okay. In this way, you can purify the metal. Then there is final topic like can I produce some gases by decomposition? This is called chemical decomposition. So you have a gas chamber that is water and you put two electrodes. One is plus, one is minus. So this is plus charge, negative will come here. So if you give energy, what happens? You breaking this bond. So you have free H plus and free O minus, right? So which will go here? This is plus, negative will go. So more of O minus will be here. This is negative, so more H plus will be here. Okay, so O minus is there, so this is anode. H plus is there, so this is cathode, and this will form hydrogen. This will form, this two will form oxygen. So you put a tube here and separately take out oxygen, and you put a tube here. So the electrode is inside a tube, glass tube. So you take hydrogen, gas. So in this way, this you can use for hospitals or rockets, combustion, need oxygen. And for this one also you can use for any burning fuels, cars, hydrogen cars, clean energy, something like that. You can use it. Now we have like made oxygen to decompose into its constitutive elements by using current. This is called electrolysis. Okay, so let me quit this one and go back here. So I think this is kind of exhaustive. So we will stop here today. Thank